Well, hi there and welcome on a new episode on TypeScript design patterns. And in this episode, we will be discussing the state pattern. So when we look at the definition, it states that it allows an object to alter its behavior when its internal state changes. And the object will appear to change its class. And it's not really appears to change its class, but the behavior changes, which make it looks like that the object indeed has changed completely. So let's have a look at a class diagram. When we look at the UML diagram, we have a context, an object, which has a request method. And instead of handling that request itself, it will forward the request to the current state of the object, and that current state will handle the request. So when does that come in handy? So if you have an object that has like 5 or 6 different states, and you call the request method, then inside that request method you would have to if else or switch all available states, and based on that change the actual behavior of the request method, which might make it very complex to maintain your class. So especially if you add states or add several methods, and all these methods are depending on the current state of the object. So indeed, instead of handling the request itself, we just forward the request to the current state object, and that current state object will handle the specific request. So I created an example. Let's head over to Visual Studio. What I did, I created a music player. So think of an MP3 player or just your old-fashioned cassette player. The first thing I did, I defined an interface for the state, and the music player has actually 3 actions. You can start music, you can stop music, or you can pause music. And based on the state of the music player, when you hit pause or stop or start, we need to execute some different actions. So let's look at the state objects I've implemented. The first state, which is the default state, is the stop state. And we pause in the music player, and what we do when we hit the start button, because it is in stop state, we log that we now start playing, and we change the state of the player to the started state. If you, however, hit stop or call stop in the already stopped state, you get already stopped and there's no further action executed. When we hit pause in the stop state, indeed no further action is executed because it's not started. We then have a started state. So when we hit play or start in the stop state, we transition our music player to the started state. And in the started state, when you hit start again, when you the method start will be called, and it will just log that it is already started. When the stop button is hit, or stop method is called, we will indeed normally would stop playing music, and then we change the state of the music player again to the stop state. When you, however, hit pause, call the pause method, we pause the music and we change the state of the music player to the pause state. Let's then have a look at the pause state. The pause state, of course, if you hit start, it will continue to play and switch the state of the music player to the started state. When we hit stop, we stop the music and we move to the stop state again. And when we hit pause, it states, well, sorry, I'm already paused, so I do not do anything. So as you can see right here, there are no complex if-else statements. We just handle the request for the current state of the object. And this allows us to work more easily with a music player. So here we have the music player, and the music player is just a very simple object that has a current state. We start with the stop state, and then we hit start, stop, or pause. That are the only methods that we have. And instead of the music player taking care of, for example, if me state, if this state equals stopped, blah blah blah, then do this, or make a switch statement, make it all very complex. We just call the current start method of the current state. So then when we look at our load method down here, we see that we can just have a music player. When we hit stop, it will of course say, I'm sorry, I'm already stopped. When we hit start, it will start playing music and change its state. When we then hit start again, of course it states, sorry, I'm already started. We can then hit pause, we can start again, and we can stop. And the result of all that is over here. Like I mentioned, when we create a new music player, it is in the stop state. So when we hit stop, it states I'm already stopped. When we then call start, it starts playing. When we hit start again, it says sorry, I'm already started. When we hit pause, it will pause playing. When we then hit start again, it will continue playing. Instead of start playing, it will continue playing. And then we hit stop again, and then it will be stop playing. And that is how you use the state pattern.